Introduction to the lab today. So if you click on the link, it should take you immediately to the lab. And in the lab, you're going to be actually working both with springs and pendulums. The first part, you should be able to click on the link shown, and it should open up a nice little web page that looks like this, and you're going to go to Intro. And the first section here, you're going to make sure you set the spring constant to small, and you're going to click on Natural Length and Equilibrium Position. Select both of those. And then you're going to grab a ruler over here on the side and just drag it over. And the first mass you're going to hang on this, and you can actually kind of line it up with the blue equilibrium position. First mass you're going to hang on here, if you look at the data table, the first mass you want to hang on there is the 50 gram or 0.05 kilogram. So if you do that, hang it on there, you'll notice it actually oscillates. To stop that, you can click the stop button, and it'll tell you actually where it's at. And if you look closely here, each notch here is a centimeter. So for the 50 gram mass, it looks like it's about 16 or 17 centimeters. And so over here in your data table, you'll go ahead and put in the weight, that's the force of gravity on the 50 gram mass. Use 9.8, not 10 for gravity. And your displacement then would be just 0.16 or 0.17. And then you can calculate the spring constant a little bit later. Next, you're going to put on a 100 gram mass. So you'll go back over here. You can remove this one, grab the 100 gram mass, hang it on there. Again, it's going to oscillate. Hit the stop button, and you should be able to figure out exactly how far it stretches. In this case, it's about 33 centimeters. So 0.33 is what you'll enter in for your displacement. How do you calculate the force constant or the spring constant? If you look a little bit further down, you can sort of see it here. The weight is just mass times gravity. That's the force on the mass. It's going to equal to K times X. We're dropping the negative sign because we're not interested in too much on that part. But we are interested in the K. And so you can rearrange this equation to solve for the spring constant. I was going to write it somewhere. Oh, you can sort of see it here. So K is going to equal the force that you hang on it divided by the displacement, where this number up here is going to be mg, your hanging mass times 9.8 meters per second squared. All right, you should be in pretty good shape. Give this first part a try. I'll make a second video for the second part.